Hi everyone, as Soumik has already discussed the brute force solution for solving the above problem. So let us see the optimized solution using dynamic programming. Dynamic programming has the power to convert any exponential time complexity solution to a polynomial time complexity solution by avoiding the overlapping subproblems. So let us solve the problem using dynamic programming. So this is the grid that is shown in the above question. Now we have to process the first column, then we have to process the first row, and then fill out the rest of the values. So in the first column we have to take the prefix sum value, that is consider this particular cell. We have to add its previous row value to this, and as well as for this cell we have to add the previous value that it had got after adding this value toward this, and thus becomes the final answer. That is, we have to add the 1 to this current cell, which becomes 2. Then I have to add this 2 to the next cell, that becomes 6. Now we have to process the first row, add 1 to this particular cell. There is no cell before 1, so we're not adding anything. 1 plus 3 becomes 4, and for this cell we have to add the result that we got in the previous step to this step. Now 4 plus 1 becomes 5. So for the rest of the cells we perform a particular operation, that is find the minimum value between 2 and 4, that is its adjacent cell towards the left and adjacent cell above to it. Finding the minimum value between 4 and 2 and 4 is turns out to be 2, and at 5 the 5 is taken from this cell value, thus the result has become 7. Now again find the same formula, apply the same formula to the next cell as well. Now you can see that the 7 is get replaced. Find the minimum value between 7 and 5, which turns out to be 5, and add 1 to this with the cell has already has, and the result becomes 6. So apply the same formula for the next two cells. Find the minimum value between 6 and 7, which turns out to be 6, and add 2 to it, which is 8. And similarly find the minimum value between 8 and 6, which turns out to be 6, and add 1, which is taken from this cell. So the answer to this problem turns out to be 7. So it clearly indicates that the minimum path sum value that you can get given a grid which is 7 is the minimum sum you can ever get from the above possible problem. So earlier we saw that the tree goes on brute force approach, and it turns out to be an exponential solution, but this dynamic programming has converted the exponential time solution into a complexity which runs in polynomial time. So let us discuss the time complexity in more detailed manner. So if n is the size of the grid, the number of elements we process is n into n. For example, if the size of the grid that we have seen in the above example, it turns out to be 3, so there were 9 elements, so we have processed all those 9 elements. Now the time complexity, which is nothing but n cross n, which becomes n square. So this is how we convert a polynomial exponential time complexity into a polynomial time complexity, and this is how dynamic programming is performed. Thank you everyone for listening to this lecture. Thank you all.